Hello everyone, we are back with another very standard question, and this is based on recursion and backtracking. So the question is very standard. I remember seeing this question in my textbook when I was doing BTech in CS. So the question is very straightforward. We have been given a n, that is the number of squares in each row or in each column, and we'll have to design a chessboard, and we have to place the queen in each of the row and in each of the column. Okay, but the catch is that you don't have to, they should not be attacking each other. So in chess, how the queen attacks each other is, like, let's say this queen is there, we are, or maybe I'll create a chessboard or n cross n matrix for this. So what happens is, let's say we have this matrix of 4 cross 4. Uh, okay, things are not proportionate over here, but okay. So this is a queue. There is a queen placed over here. So it can attack all the blocks in its diagonal. That is basically this block, this block, this block, and even in this diagonal. And it will attack in this row and this column. So that's all. So for example, this particular block is empty, it won't be attacked. This particular block is empty, it won't be attacked. So our task is to basically place the queen in all the rows and in all the columns. So basically there should be one queen in this row, one queen in this row, one queen in this row, one queen in this row. So that's how it has to be. And similarly in all the columns we have to have something. So how we have to do is, first just quickly see how normally we'll be doing it. So just like trying the backtracking process. This actually explains the backtracking very nicely. So what happens here is, like, this time I'm trying to draw it little finer than previous. So what happens over here is we have this 4 cross 4 matrix again. So what we do is we keep the queen over here, and then in this row we have to find which particular block is not attacked. So this is attacked, this is attacked, all these are attacked, but these two are free. So let's put it here, and let's now we'll go to the, so we basically tried in this and then they were not possible, it was not possible because it was attacked. So we tried in this and it is possible, so we keep it here, and then we come in this row. So in this particular block it is not possible being attacked from here. In this particular block it is not possible being attacked from this queen. This is also not possible, this is also not possible. So we are basically at a dead end. So because none in this particular row we are not able to keep the queen in any of the block. So that is a problem, right? So we have to straight up do one thing. We go back to the previous uh, level. I would like to say previous recursive stack, because that's how we have like implemented it, and we don't keep it here, we keep it here. Okay, and then again we come to the current, like the next recursive stack, and we check here. It is not possible. Here it is possible. It is not attacked from anywhere from here, anywhere from here. So we can keep one here. Cool. Now we come to the next row, immediately to the next row. Here it is not possible, here it is not possible, here it is not possible, here also it is not possible. So again we saw that it was not possible in any of the blocks over here. So we go to the previous block or previous recursive stack, and we remove the queen from this particular block, and we try to keep it in other blocks. We see that we can't keep it here, we can't keep it here. So basically we have came to the end of this particular block. Okay, and this particular row. So basically that means that we have to go one recursive stack even further. We came even like we have to go to one recursive stack back than the current. So we return over here. We see that even if for this row we are at the last block, so we don't have to, we can't basically keep it here as well. So we remove the queen from here as well, and now we again return to the previous row. In this row we see that with this particular placement of queen, we were not able to get the answer. So what we'll do is we'll remove it from here and we take the queen to this particular block. Now I'll make it quick. Now, if you do the same process, you check here, here, here. We can't keep it. We can keep it here. We keep it here. Then you come to the next row. We can keep it straight up here. It is possible. So we keep it there. And then we straight up keep it here. Okay. Because it is not being attacked. This is a solution. We see that queen has been placed in all the rows. So we add this particular configuration to the answer list that I'll explain while I'm showing the code. And so this is the way. And what we have to, and even in this case, once you reach n, once the row number is equal to n, we have to return back and we have to try the other combinations as well. Here we can't keep queen, here we can't keep queen, here we can't keep queen, so we will go back. None of the places we can keep queen, we can keep till, while returning from the recursive stack, we'll see that we can keep the queen over here. So again, we'll keep the queen over here and we'll try all the combinations. So that's how we have to do it. So this is a straight up solution. This very well explains how backtracking with recursion works. So that's the thing. After this, we'll just quickly see the code. So in the code, you can see, I'll explain why are we using this function verify. But before we do that, we have to understand what are we doing currently. So currently what we are doing is we have a function named solve, just the way we always have it. And in that function, we have passed two things. One is row and one is array. So what is array? Array is a basically n spaces. So it's initially, let's say we have, like if we take the example of 4, so we have 4 into 4. Okay, like there are spaces, there are 4 spaces. I'll maybe explain it here itself. So it's like there is one array named array, and we have 1 2 3 4 4 spaces. Then we have again 4 spaces. Then we have again 4 spaces, and this way we have it. Okay, so that's basically 4 spaces 4 times. We have one once more. Okay, so that's kind of a doubly linked list of strings. So doubly sorry, doubly double array 2D array of strings. So that's basically like that. And we have to add all the queens in the placement, like how we are going to place it in the chessboard, and that's what we are going to do. So for example, for this particular uh, scenario where we have kept it in this, what we are going to do is we have to, as per the question, we have to add dot for the empty places. So we have to basically put dot queen dot, then again dot queen, then dot queen dot, then again dot uh, oh, this one was wrong. So it is queen dot, and then again it is going to be dot queen dot. This got me confused, but the queen is over here. So that's how we do it. So this is basically one of the configuration that is possible. Okay, so at the end, what we have to do, there is an answer list in which we'll add this configuration. So if you see, that's how we have the example has also been given. You can see that for there is a list of list, and that list is like a 2D list of strings where we have dot quin dot quin. In this format we have all the configurations. Okay, then again, once this is done, we'll have another configuration, that is dot queen dot and queen dot and so on. So that's basically, yeah, one of the array list has one configuration. Similarly, other array list will have another combination, and all of those correct configuration will be added to an answer list at the end. So that's there. The solution was very straightforward. You will currently observe that it was not at all tough. Uh, But yeah, again, if you're doing it for the first time, you'll have to put in some brain. It is at hard level on Leetcode. So what we do is we have a recursive function named solve. In that recursive function, while we are calling it, we are passing the 0th row and array. Array is basically one correct configuration. So that's basically this correct configuration, one correct configuration. It is supposed to be that. Currently, it is just n number of n strings with and empty spaces. We initially haven't even added dot, so that's how it is. We have passed it to the solve function. Here we create a temp variable. We'll see how it is used. We create another. We check like once the the value of row reaches to the end, that is the n, then we have to, that means that all the rows have passed, and we have seen that the recursion has reached to the row beyond this as well, like after 3 also it reached to 4. Okay, that is 0 1 2 3, it reached to 4. So once it reached 4, that means that all of these levels have got one queen, and in that scenario we'll just simply add the array configuration to copy the array configuration to the answer list. So that is there. After that, what we have to do is we have to have the loop run from. So why is this loop used? It is used for uh, placing the queen in all the blocks. Okay, so we place the queen in this block, we place it in this block, we place it in this block. So for that purpose we have used it. So now you will see, since the number of columns are also n, the loop runs from 0 to n minus 1, basically in the range of n. And we have a function called verify. Verify, what it does is, for all the placement, let's say we are right now talking about the second row. Okay, 0 1 2 second row. So it will check for this first block. It will check whether at this block queen configuration is possible or not, because there are other two rows are already populated. So whether placing queen at this particular block, will it conflict with any other block or not? So this is what is checked in the verify function. How we'll check it? It's also very straight up. I'll just explain it after this. So if it satisfies, what it does is, if verify returns true, it this temp string, in the temporary string, basically we append a queue. Okay, so once that queue is appended, then for the remaining three blocks, we'll append a dot. So for that purpose, first I append a queue, then I append a dot into n minus I minus 1. So if you calculate, this 3 will be like n minus I minus 1, based on where we have, what is I, where we have placed the current queen. So that's how we add dot. And after that, we have that. We are taking a, yeah. So what we are doing is, we are uh, take saving the current restore. Basically, this particular variable is restore. I have created it to save the current configuration of array. Like currently, array is having dot queen dot queen. So currently these two rows are populated. So that particular configuration, I will save it. And for the last two strings, it is just having 4 spaces. Okay, so that will be stored in this particular variable. After that, in the current row of array, in this third row of array, we are adding that temp, that is basically q dot. We are adding it in the current row, and then we are calling the same recursive function again, and we are reaching in this particular row. Okay, so that's what we are doing. Solve row plus one and array, the array which we have modified, the new array we are doing it. Why we are restoring the previous configuration into a variable, that I'll let you know. So once that reaches solve, so again in this particular row, for this particular row, it will check whether the row is equal to n. No, it is just equal to 3 right now. It is not equal to 4. So it will come here. Then it will again try to place it here. So it will check verify whether 3 1 3 0, whether at 3 0 is, if placing queen there, is it correct? Will it have conflict, or it will not? So it will call verify function with those two values, row and current column I, where we are going to test, and it will check. So if it is possible, but we know it is not possible over here, so what it will do is, it will come in else part, and for the temp it will just add dot. So that's basically what happens is here. I'll quickly explain. So basically, let's say in the fourth column, fourth row, if we have to test in these four columns. So here, if we test it, so we verify returns that it is not possible to add here. So we'll add in temp, we'll add one plus equals to one dot. For this also, we'll add one dot. So temp is currently uh, two dots. Okay, and that's there. And then we have to test for the third particular block. So we see that in the third block it is possible to add a queen. Okay, so what it will do is, for the third block it will temp it will basically in this function it will return true. So it will add a q. So temp will become dot q, and will also add this particular, you see we are adding dot into n minus I minus 1, so we have to also add one dot over here. So that's there. After this is done, so the temp will become dot q dot. Okay, dot q dot. So it will, after this it will again call solve, and after doing going for the next row that is equal to 4, so it will see that we have reached to the row 4. So it will append that answer to that array value to answer. And we are using the split method just because it copies the copy of array string. It doesn't copy the reference to it. It doesn't create the reference to it. So that's there. Once that is done, we'll return. Now what we do is, like, let's say we have tested this. Okay, we have tested this particular scenario in which the queen is added over here, the queen is added over here. Okay, for the next scenario we also have to check whether the queen is added over here. Okay, what happens if the queen is added over here? Does it also give us the solution? So for that purpose, we created the restore list. Okay, restore list was created for that purpose. Okay, so what happens is, now you can see after the solve function returns from the next row, it has evaluated the next row, it returns. So in array row, we put restore back. Restore. So array row will become again, the first two will have something. First two will have dot queen and dot queen, and this will also have, third row will also have queen dot. But this particular thing which was currently temp became this, right? We just saw that dot queen dot, it became this particular thing. But after copying restore, this will be removed because restore was already having the previous value. So this will be removed, doesn't mean that it will have two elements. It will just have the empty spaces again. So it will have the empty four spaces again. So now it will evaluate for the last position. It will start evaluating for this particular position. So that's how it will work. Now we'll go to the verify function. Verify function is straightforward. The reason is, I'm pretty sure it is easy because I explained it to one of my brother who is in class 6th, and even he understood. So I explained it this to him in one simple way. We have to have four rules to define whether a configuration can be added or not, or queen can be added at array I or not. Uh, so, okay. So we will discuss, God, we'll discuss this for this particular block. Okay, so we have added one queen over here, one queen is added over here. First we'll quickly name the rows and columns the way it is named in 2D array. So this will become, this is basically 20. 20 is what we are testing it for. So 20, what we have to do over here is, there are four rules. Rule number one, and this can be figured out just by observing it. First rule is simply, you can't add it in this particular row. So that's what we have seen here. We run our doubly, like, to nested loop. In that we see that p plus q should not be, oh, okay, this is the second rule or third rule. P cannot be equal to r. So basically this particular row cannot be equal to what is passed to verify. So p has been passed to verify. Rule number one is 2 has been passed to verify. And so whatever 2D doubly for loop is running, that for loop, if p, that is the first variable outer loop, is equals to 2, then there we cannot add the queen. Okay, so that's the first rule. The second rule is if the q, the second loop that basically signifies the column, that should not be equal to the value which is passed over here, that is c. So it should not be equal to, I have defined it in different way. If p equals to r, if q equals to r, uh, then and in that particular row, if we see that there is already a queen, so basically there is a two nested loop that are running. So if we see that there is a queue in this column, or if we see that there is a queue in this particular row, okay, so in that scenario, so that's what I'm doing. I'm checking either p equals to r or q equals to c, and nested all these four rules which I'm going to explain, and having one of these true and having a q in that particular scenario. And that for that particular p or q, if we are having a queen placed, then we have to return false. So, and the other thing is, this is going to be interesting. So if you see, how do we see the uh, basically the this diagonal? So let's see what is common. So this particular, I'm currently discussing about this particular column, whether we can place q over here or not. So what is common in this? The index for this will be 1 2. Okay, and this diagonal element will have index as 0 1, and this diagonal element will have index as 2 3. Okay, so that's how we have it. So you can see for this particular diagonal what is the scenario. So you will see that whatever value we have passed to verify function, that is 1 2. Okay, if we minus 1 2, and the 2D loop which is running based on p and q, if we minus p and q, if they are equal, okay, if 1 minus 2, that is, and from the code you can see, if r and c that are passed, if r minus c equals to p minus q. Okay, so if this is the scenario, so in for these three examples you can see 1 minus 2 equals to minus 1. Similarly, 0 minus 1 is minus 1, 2 minus 3 is minus 1. So in this scenario, so we have rule one became that r equals to c. Rule 2 became, no, not r equals to c, r equals to p. Rule 2 became that c equals to uh, q, and rule 3 became, okay, rule 3 became that is r minus c equals to p minus q. Okay, so the 2D loop which we are sorry, doubly the nested loop which we are running, whether p minus q equals to r minus c. And for this diagonal, similarly for this diagonal, you will see the sum has to be calculated. So this is 1 2 1 2, so this is 3 0, this diagonal element is 2 1, this diagonal element is uh, what is it? It's 1 2. This diagonal element is 0 3. So these are the three diagonal elements. So you will see the common thing is the sum is same. 3 plus 0 equals to 2 plus 1 equals to 1 plus 2 equals to 0 plus 3. So in all these elements, we can, if we see a queen, then we have to return a false. So that's what we see. If p plus q equals to r plus c, if p equals to r, or if q equals to c, or if p minus q equals to r minus c, any of this condition is true. And in that scenario, if pq is having a queen placed, so that's basically if for this block in this row if it is there, if in this column if it is there, either in this diagonal if it is there, or in this diagonal it is there, in any of the four scenario, if we have a queen placed, then we are putting false in the value and we are returning false. You can ignore the comments which I added. So you will return the value as return the value that is basically false. Initially we have the value as true, we are setting it false if the condition meets, and we are returning it. So yeah, that's how we do it. So that's exactly same as how I explained initially the solution will go. We first place queen over here, then we check for this row. This was the possible place we could keep, but after keeping it here, we were able to find that in this particular row we were not able to place. So we return to the previous row, previous recursive stack. So that's basically, let's say if that's basically like saying ki, I came to this particular row, I tested whether verify, this verify tested whether queen could be placed here. No, it could be placed here. No. In the scenario, when I'm saying in this scenario, let's say in this scenario, uh, in this scenario, we keep q here, we keep q here. So we tested verify told that we cannot keep it here. Okay. Then verify told that we could also not keep it here. Okay. Then verify told that we could not keep here. Okay. Then verify told we could not keep here. So if we could not keep it anywhere, so that's why we have kept even this condition that if q is not in temp, if temp was not able to get the q out at all, we'll just simply we'll return to the previous level. So if it was not possible to place it anywhere in these blocks, we return to the previous level. After returning, what we did, so where did we return? We returned to the solve. Okay, in the previous row, that is row number 1 in this row, we returned it at this particular scenario. And then we again restored the array, the current configuration. So we restored it to having first properly the row 1 properly, the row 0 properly, and this particular row is having all the spaces. Then again we tried this particular loop for I in range, and what it did was it tried the next configuration. It tried, okay, since this was not working, so I'll remove q from here, I will have these three other spaces and I'll add q over here. Then again it will come to this loop, and this particular recursive stack using solve. Verify will tell we can't add here, but verify will tell that we can add over here. So it will add over here, and then it will come again to this particular play next recursive stack, and it will check that we can't add q anywhere. Then it will go back. Verify will tell we can't add here, we can't add here. Then it will go back. It will, the loop will tell key, okay, we are already at the end. Then it will again go back, and it will try to place q over here, and it will proceed in that manner. So that's how we have to do it. The solution was actually, the logic was very easy, but yeah, the solution gets a little tricky if you're not um, if you have not seen it. For example, this particular place where we are modifying the queue, we are adding dot, and we are creating a temporary reference to the list, and we are restoring the list back. All these things get a little complex if we have not seen the question in very long. I took nearly a day for for solving it after college. Like I did it in college, now it took nearly a day. But yeah, now it will go in my notes and I'll start revising it. Same is what you have to do. And believe me, the first and foremost thing is that you should not be solving it or seeing the solution directly. The logic you have to build on your own. The solution you have to try building it on your own, and take your day, take 2 days, take as long as you want, and try it on your own. If you're able to do it, fine. If you're not able to do it, you can see the solution. And thanks for watching this video. Thanks a lot. And I'll be bringing the matrix chain multiplication 2D arrow approach. I know I've been telling this for very long, but now that is the next video I will be recording. So thanks a lot for sticking till now, and have a great day. Happy coding. Bye bye.